Today we'll look at the proof of the compound angle sin x plus y cos x plus y and tan x plus y. On our screen is a rectangle which we have a right angle triangle inserted. There's a right angle triangle with this side 90 degrees. The value of this angle is x and that of the bottom one is y. The whole of that place alternate with the top here. That should be x plus y, alternating angles. Remember, the opposite sides of a rectangle are parallel. Then let's make the value of the hypotenuse equal to 1 and label the other side of the shape. Let's call here A, then B, the small size here C, D, small here, the small length here E, F, G, and H. Good. If here is Y, then obviously here will be 90 minus Y. If here is 90 minus Y, and here is 90, using the properties of angles on a straight line, they should be Y, so that the sum of the three angles is equal to 180 degrees. Then we use this triangle to find the value of the sine of the angle x plus y, which is equal to the opposite, which is A, over the hypotenuse, which is 1. And since anything divided by 1 is the same thing, so sine x plus y is equal to A. By looking at the diagram, our A is equal to the other side. Our A is equal to D plus E. Opposite sides of a rectangle are the same. So A is equal to D plus E. We'll now find an expression for D and E and use that to represent our A. So let's go to D. D in this triangle is the adjacent side of the angle Y to the triangle. So so we have to use cos there. So cos Y is equal to D over H. Making D the subject, D is equal to H cos Y. We don't want H to be there, so we'll find an expression for H by using this triangle. Using this triangle, H is opposite to X, so we'll use sine. So sine X is equal to H over 1. So our H is equal to sine X. Our H is equal to sine X. So we're writing our D. Our D now will be equal to sine X cos Y. We have gotten D. Let's look for an expression for E. When we come to E, E is opposite to Y. E is opposite to Y, so we'll use sine to find that one. So sine Y is equal to E over 8 hypotenuse, which is J. Our E is equal to J sine Y. We don't want J, so let's find an expression for J. Let's find an expression for J using this triangle. So using that triangle, we can find an expression for J by using cos. Cos x is equal to J over 1, which is still J. So it means J is equal to cos x. So our E now become cos x sine y. Now that we know our E, we know the value of our E, which is cos x sine y, and we know our value of D, which is cos x cos y. We can now write a new equation for our sine x plus y. Remember, first we said sine x plus y is equal to A. And we said A is equal to D plus E. Hence, our sine x plus y will be equal to the D, which is sine x cos y. Sine x cos y plus our E, which we got down here as cos x sine y. Cos x sine y. So this shows that the compound angle sine x plus y is equal to sine x cos y plus cos x sine y. So that is that. In the next video, we'll look at the compound angle for cos x cos y.